Hello, my dear students. Hope all of you are doing well and maintaining good health. I am Dr. Smruti and I welcome you all to Etuson, Education for Better Tomorrow. It's a digital learning platform for Odia and English medium students. If you believe in quality education, then you are in the right platform. As in Etuson, we provide quality education which will definitely help you to build your career. Then what are you waiting for? Please download the eTuition app and enroll yourself so that you can avail all the facilities at your fingertips. So students, without wasting much time, let us start today's class. So today we are going to learn some of the theorems related to similarity of triangles. So are you curious to know what it is? So let us start. What do you mean by similarity of triangle? So two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. Remember, corresponding sides has to be same ratio. It is not that like some side are in the proportion, then you cannot consider as similarity. So corresponding sides, so in order it has to be in the same ratio. Need not be of same size, but it should maintain a correct ratio. Remember, that ratio is called representative fraction. We have learned in the previous class, right? So, two triangles are similar if their corresponding angles are equal and the corresponding sides are in the same ratio or proportion. Correct? If corresponding angle of two triangles are equal, then also the angle is known as what? Equiangular triangles. That means if all the angles of a triangle is equal to all the corresponding angles of another triangle, then the two triangles are said to be angular triangle. Why equiangular? Because all the angles are equal. Correct? Hope you have understood. A famous Greek mathematician Thales gave an important truth related to two equiangular triangles, which is as follows. The ratio of any two corresponding sides in two equiangular triangle is always the same. Okay, it is believed that he had used a result called basic proportionality theorem, which is otherwise known as Thales theorem for the same. Okay, because he has used it, the concept to find out the ratio of the corresponding angles. So the theorem is uh, behind his name, that is called Thales theorem, otherwise known as basic proportionality theorem. So let us learn the theorem now. So this is theorem 6.1. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Okay. So if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So let us understand this theorem. So we are given a triangle ABC. Okay. So this is your triangle A, B and C. Okay. What you have to do now? You have to draw a line parallel to BC. Okay. Intersecting the other two sides. What are the other two sides? So other two sides are AB and AC respectively. Right. So we are going to draw a line parallel to BC. Okay. So this is the line DE. this is the line DE, which is parallel to BC. So this DE is parallel to BC and intersecting the other two sides. What are the other two sides? AB and AC at point D and E respectively. Correct? So what you need to prove now? You have to prove that it will divide the sides with a same proportion. So when you divide by point D, what are the different segment you got for AB? You got here to here one part, here to here another part. So you got AD. So D is dividing AB into two parts, that is AD and DB. And similarly, E is dividing AC with two parts, that is AE and EC. So according to the theorem, you need to prove that AD by DB is equal to AE by EC. So you are taking the corresponding proportion, remember. So this you need to prove. So this you need to prove. Okay. So you need to prove that AD by DB is equal to AE by EC. Now let us join BE and CD. Okay. So what we have done? We have joined points from, I am just highlighting to make you understand. So we have joined C to D. Okay, so this is how it has been joined. So and here B to E, right? So then what we have done? Then we have done drawn the perpendicular from the point D on AC and from point E on AB. So from DM you have drawn one perpendicular. Okay, so this is 90 degree. Similarly from E also you are going to draw one perpendicular. So now from this DM is perpendicular to AC and EN is perpendicular to AB. Very clear from the diagram. So now area of triangle ADE. Area of triangle ADE. Okay, so this triangle we are considering area of triangle ADE. What is the formula for area of a triangle? That is half into base into height, right? So what is your altitude is given because you have only plotted the perpendicular. So you have plotted this EN. EN is perpendicular to AD. So you can consider base as AD because you have plotted the corresponding altitude. So half into base. So half into AD into corresponding altitude, which is EN. Correct, children? Hope you have understood. This is the area of the triangle ADE. Okay. So now if you remember, the area of triangle is denoted by area of a triangle. Suppose here ADE in this case can be written as area ADE. Hope you remember this was taught in class 9. So now in case of writing every time area of triangle ADE, I can just write down AR for area. So AR ADE is equal to half into AD into EN, right? Similarly, what will be the area for triangle BDE? For the triangle BDE. How to find out? So we know that AB is AB. On AB you have plotted this perpendicular EN, right? So here it is written. So as we know, EN is perpendicular to AB. So EN can be considered as altitude for triangle BDE also, right? because we know that EN is perpendicular to AB. So from this you can take that EN also altitude for triangle BDE. So area of triangle BDE is equal to again half into base into height. So what is base here? Because you have altitude corresponding to AB, right? So you can take half into dB into EN. Half into dB into EN, right? Okay. Similarly, area of triangle ADE is equal to, okay, we can write out in another form also. What is the area taking other base into account? So other base into account, because you have plotted two altitude here, one altitude from E, another altitude from D. So considering the altitude DM, because we know that DM is perpendicular to AC, right? So considering that, you can find out the another area of triangle ADE, correct or not? And what will be that? So that will be half into, if we consider base here as AE, corresponding altitude is DM. So half into AE into DM. So area of ADE is equal to half into AE into DM. And similarly, if you will find out the triangle, area of triangle DEC, that will be equal to half into base EC, right? Because we know that your DM is perpendicular to AC. So you can consider this as altitude of this triangle also, that is DEC's triangle. So on the basis of that, you can take half into base into height. So base is EC and the corresponding altitude is DM, correct? So that is half into EC into DM, correct? So now you have found out the area of all the triangles. So now let us take the ratio. Now area of ADE divided by area of BDE is equal to half into AD into EN divided by half into DB into EN. So this we have already found out in the previous slide, right? So we have just substituted the corresponding value. So when you take these two area, you get AD by DB. Similarly, if you take the other ratio, that is triangle ADE by DEC. So let me show that triangle again. So here ADE by BDE, another one is ADE by DEC. Okay, so same thing we have done and substituted the corresponding value. So you have got the ratio of area ADE to area BDE is equal to AD by DB, and ratio of area ADE and area DEC is equal to AE by EC, right? So now note that triangle BDE. So what we have to note here? So let us see. So you see here the two triangles, that is BDE, okay, triangle BDE and DEC, they are in between two parallel lines, right? So that means, and having a common side. So that means area of triangle BDE is equal to area of triangle DEC. This you have already learned, right? So area of BDE is equal to area of DEC. So if you substitute this, so that means these two are same. Okay, so if these two are same, then equation 1 is equal to equation 2, and you got AD by DB is equal to AE by EC. Correct, children? Hope you have understood this theorem. Okay, so now let us go to the next theorem. It is a smaller one. So theorem 6.2. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Okay, so this theorem can be proved by taking a line DE such that AD by DB is equal to AE by EC. Okay, so what you have done, just arbitrarily you have drawn DE, Okay, such that you have to maintain, while drawing the line DE, you have to maintain the ratio. What is that ratio? AD by DB is equal to AE by AC. So now you don't know that DE is parallel to BC. It may not be parallel. Okay, so assuming that DE is not parallel. So now if DE is not parallel to BC, so you can draw a line parallel to BC, which can be considered as DE dash. Okay, so it will intersect the line AC at some point E dash. Okay, so now AD by DB is equal to AE dash by E dash C. Why? According to theorem 6.1, basic proportionality, correct or not? So AD by DB is equal to A dash by E dash C, basic proportionality. So but you have drawn the diagram such that AD by DB is equal to AE by AC. That means, so from these two, what you can take is AE by AC is equal to AE dash by E dash C, right? I can write down here. How you got it? So AD by DB is equal to AE by AC. So that means you can, instead of AD by DB, if you write AE by EC, that is equal to AE dash by E dash C. Right? So when AE by EC will be equal to AE dash by E dash C? Only when E and E dash are not different points, rather they are coinciding with each other. Okay, so if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So this is your theorem 6.2. So hope you have understood both the theorem. So we will in the next class we will be learning how to implement these two theorems for solving different problems. Thank you children for your patient hearing. Please like, share and subscribe our channel. Download the Etuson app. Follow us in Instagram, Twitter and Facebook. Okay children, keep smiling and keep practicing and take care of yourself.